In this video, we're going to be talking about what we find when we integrate the rate of change. Here's the important thing that I need you to keep in mind. If you integrate the rate of change, you will get the amount of change that has taken place over a time interval. Let's look at a few specific examples. In this first example, what we've been given is the rate of change of the number of mosquitoes on Tropical Island. It's represented by this function here, which is measured in mosquitoes per day. So notice what we have is a rate function. If we were just to evaluate this at a t-value of 14, for example, we would be finding the rate of change in the number of mosquitoes on that particular day. If we were to take the derivative, we'd be finding the rate of change in the rate of change. But what happens if we integrate the rate of change from 0 to 14 of r of t dt? Remember that we're integrating the rate of change in the number of mosquitoes. One hint that we might use is to put some units on this. R of t is measured in mosquitoes per day, and dt is measured in days, and so the days will divide out, and what we're going to get is going to be measured in mosquitoes. I'm going to go ahead and put this definite integral into my calculator. And so you can see I have it entered here, the integral from 0 to 14 of r of t. I'll hit enter, and it's going to take a moment to add it up. And you might be surprised by the result. Notice we get negative 17.74. Well, I'm going to go ahead and round that off to the nearest integer. Negative 17 mosquitoes, it certainly isn't the number of mosquitoes, though some people might think that would be nice to have a negative number of mosquitoes in your yard. The fact is, this is the change in the mosquito population. It tells me that there are 17 mosquitoes less after 2 weeks than there were on the first day of the month. And so this represents the change in the number of mosquitoes during the first 2 weeks of the month. Change in the number of mosquitoes from t equals 0 to t equals 14 days. Notice it's the change in the number of mosquitoes. It certainly isn't the number of mosquitoes. That's the important thing that you need to keep in mind. Here's another example. In this case, we have two rates that we're going to be dealing with. The tide removes sand from Sandy Point Beach at a rate modeled by this function. So this is the rate that sand is removed. And simultaneously, a pumping station adds sand to the beach at a rate modeled by this function. So we have sand being removed and also sand being added. Remember that these are both rates. If I were to do an integral from 0 to 6 of s of t minus r of t dt, remember this is not going to give me the amount of sand on the beach. It's going to give me the change in the amount of sand. Notice that I have the amount being added, and here, when I subtract, integrating r of t is going to give me the amount that's being removed. So, again, let me go to my calculator, and you'll notice that this time I've stored these functions at y equals, and I've entered my integral into the calculator. I'll go ahead and hit enter. And again, notice that I have a negative result, negative 6.723. Negative 6.723. And this is going to be measured in cubic yards of sand. So, cubic yards of sand. This certainly isn't the amount of sand on the beach. This is the change in the amount of sand on the beach. So remember that when we integrate a rate of change, what we're getting is the amount of change that has taken place over a time interval. That's the important thing that you need to keep in mind. Thanks for listening and enjoy calculus.